Okay, let's get started with the spine. So similar to how we started last week, we are going to just build our rigging components here at the geometry level, and then later we'll build our HDAs how we need to and promote our parameters as we need to and want them. This week I will mostly just be exploring how we set up the different systems rather than focusing in on each individual thing. We won't go over promoting parameters and creating the HDAs. I will leave that to you guys in between lessons. So we'll just go over setting things up, and you guys can finish it off with the information you've learned so far. So first, let's just start like we always do. We will, since we have our whole main chain here off of our cyborg legs, we'll just separate out the aspects that we need. And right now, we're going to just get all of the spine. So we're going to get all of our spine and our head, and we'll just see what we can do. Here we go. We have all of our spine now. Now let's start setting it up. Let's start with something easy. We'll go in here and we'll just grab our library of nodes that we have here. Our controls. They'll be useful for us at any point. Something important to note as well, with the attach joint geo, we'll notice there's actually a third input here that says shape template. The shape template is, if you look up our attached joint geo in side effects library of nodes, it'll say that the shape template is a file or template geometry that you can load up, an actual library that you can pull from a file and attach in there and reference any of the controls from that template of systems. So our library is like our created geometry that we put in, and our template is something we reference from outside of Houdini. So let's continue with our spine here. Let's start with just creating the FK system, since it's nice and easy. We'll just put down a rig pose. And I'm actually just going to grab just our spine. I'll set up the neck next. So just the spine. Rig pose, FK, spine. And we can put down and attach joint geo, put that in between. We'll put our library in here. I think I'm going to edit our FK control here to be in line with the flat again, and it'll be a little bit bigger to accommodate for our body size, our torso here. So we can just spread the radius out a bit, maybe uniform it up a little bit there, and expand it in width a little bit to match our torso. I'm going to also change the color just to be orange, slightly different from our leg IKs or FKs. And we will just attach all, my bad, wrong node. We will attach all, and we'll use the FK controls. We're going to change the plane of that FK as well, back to where it was, I guess. We'll see. There we go. Perfect. So that's our FK chain set up, really nice and simple, real easy. Now let's dive into our spline IK, which is going to be a bit different than our leg IK, obviously, because we're going to be using a rig VOP this time round instead, and a curve solve. So similar to our leg IK, I personally am only going to use 3 points to control the curve of the spine. So I'm, from here, going to delete even further out and just call this the IK spine. I'm going to delete out everything but the tip, the mid, and the base. Perfect. So now we have a triangle here. I'm going to unparent everything just like we were setting up for our IK, so we can control each point individually without controlling down the chain. And I'll just take all and unparent them. Perfect. Now I can set up a rig pose here, and we can control those IK spine points. Now we'll want to set up our spline IK here with a rig VOP. So we'll take our rig VOP here, and we're going to set this up as a curve solve. So we dive inside, and the first thing that I'm just going to do is put down a solve, curve solve. Our target points is anything in our first input, our control points are anything in our second input, and we're creating a Bezier curve. So let's get our target points, our control points, and we'll want to see our inputs, which is already given. I'm also going to turn on joint axes so we can see how our system is affected. Now in order to see any changes from our solve curve, we need to put in a set point transforms, with a plural this time, simply because we can look at this as PTS instead of just PT for single point. We'll hook in our points and our X forms, and we can see that our curve solve has created a flat point here. And the reason for that is because just like our first week, we have our curve order, we have 4 points given, but we only have 3 points. Now we've entered in 3 points for our Bezier curve. We can see that the curve isn't bounding out as much as we need it to. So we can solve that by adding in an offset for our curve. And we can just do so in our IK spine here, or we can create a new rig pose for it as well. But as we draw out our point here, we can see that line, our curved solve, gets closer and closer to where we had it. We won't be able to get it perfect because we're trying our best to draw a line from our 3 points. That if you can imagine a Bezier curve kind of drawing under here from these 3 points, it'll try its best, but having the point at the same point of our spine will not curve it enough, which is why we're bringing it out. Now that our curves match pretty well, we can dive in and try and solve our orientation issue. So we like to point down the chain with Z positive. And of course our up axis was either Y, there we go, it was Y. And now our curve matches our orientation as our start. Perfect. So we're well on our way to creating this curve solver. Something that I like to do so that we don't have to pose the middle point as much is I like to create a sort of follow system for our midpoint. For our midpoint to kind of follow along with both the bottom and the top joints, we need to create a kind of parent system here, and I'm going to create a constraint as well. So I'm going to, in our parent system here, I'm going to add a new parent. And I'm going to parent our middle point under our base point. And after our posing here, I'm going to create another rigvop that will hold a parent constraint within it that'll allow it to follow along with our top point as well a little bit. Half follow tip or something like that. So we'll take our spine 2, that's our set point transform. We'll want to get our get point transform as well, and we'll also want to get our spine 4 point, and we can even get our base point as well. And we'll want to create a parent constraint. And we can see that we have this blend here, so we can actually decrease the amount that we're parent constraining our joint here, which is what we're going to do. I want it to have 50% of our power from our top joint and 50% from our bottom joint. So I'll just put this parent constraint at 50%, and that means it'll follow half of our parent or our motion from our end of our chain here. And of course it'll follow as much as possible from our top chain and adjust halfway towards our the top of our chain. And it'll follow our bottom chain because it is a child. So our spine 0 is our current parent. Our spine 2 is the X form we want to edit. And our spine 4 is the new parent. And we'll put that into our output X form. We see it span up crazily, and we'll just want to make sure we update the offset on that. And we'll want to put it at 0.5. Now when we move our top joint here, and we look at our curve, and we look at our half follow tip, we can see it follows the top of our chain there. We can see it being changed a bit. And of course when we edit the bottom of our chain, we can see it change a bit as well. So we're always at like a midpoint between. If we bow both of our points outwards, we get this nice sweeping curve, as we can see. And that's exactly what I like to instill in my spline IKs. You can choose to set up your spline IK however you want to, but this is what I like to do. Of course we can come in here and attach some joint geometry if we want to, just with a attached joint node. Perfect. One thing that I want to check for this spline IK is to make sure that twisting of our joints is working well with the orientation. So as I twist it, we can see that our point gets moved with it, and our angle is moved well. But our joints within our chain don't really twist the way that I was hoping. So we'll dive here and investigate further. Our twist mode I might set to be maybe default, or we'll test around here with quaternion maybe and see how that works. We can see that our joints now, if we dive up, have a better rotation as they go through. We can see that our input here, our Y is pointed to our left shoulder, or rather the character's right shoulder, and our base joint here, the Y is pointed towards his back. We can see that on our output chain, we slowly, with a quaternion solution, rotate that Y as we go up. And that's more of what I was hoping to achieve from this spline system. So I'm going to keep that twist mode on quaternion. And I think I'm going to put root orientation to be our control. So we can control by our rig pose and the control that we will create. I'm also going to do the same for the tip, so that any direction the tip is oriented, we have that direct orientation as well. Scale mode you can play around with, but I'm just going to keep it at target scale. Squash and stretch you can choose to add. I might add in stretch just so that we can make sure that our spine points are always at the same spot. And if someone is using the spline IK, it's kind of annoying to need to readjust your endpoints to match how the curve can be built. So I'm going to turn on stretch. Perfect. So our spline IK is pretty much done being built. I'm going to erase all our data here. You'll notice sometimes when we've gone through and locked previous parameters from setting up our leg, that sometimes our rig pose node retains that locked information. You can always come in and right click and unlock that information. If it's something to be locked in our translate or a rotate that we definitely need. Okay, let's blend these two chains together, and then we will set up the neck. So since our rig VOP holds our main chain of our spine, all of the outputs, and this is kind of our simplified chain for our okay, we just put down a skeleton blend node, and we'll allow for our animators to blend between our FK chain and our IK chain. We shouldn't have to turn on world bias since they hold the same parent structure, and it should just rotate or blend between the 2 points that we want. Perfect. I'm going to keep it to FK mode just because that's more what I think will be used for a spine. So I'm going to actually create and rename this rig pose to be offset mid, and I'll create a new rig pose, and just off the bat I'm going to turn off all visualizations on this pose because I know I won't be using it as an offset. And I'll put down a new rig pose that'll be the actual control. There we go. Now I won't have to worry about editing the midpoint again to match that curve. And it's more accurate to start, just off the bat. Perfect. Okay, now we can blend it with our main chain again. So we'll take a blend here. This is our blend spline and FK. And we'll blend it into our main chain, which we will want to be world space and always blending towards where our spine position is. So blend main and spine. Perfect. Now from this point, now that we have our spine positioned, we can start to edit our neck. Now that, in theory, our animator animates the spine at this point, and we want to animate the neck after the spine for things like a look at constraint or whatnot. If we were to solve for a look at before the spine is posed, then you might have an accurate look at for before the animator chooses to animate the spine, but after that point the spine will still be looking in whatever, or sorry, the neck will be looking at whatever it was, but it'll change based on where the spine is rotated. So if you bend the spine back and the character was looking straight forward, the character will be looking straight forward still from the neck's perspective, but it'll be looking straight up because we bent the back. So let's get started on the neck. I'm just going to set up a quick FK. We can do so by putting down a rig pose. Boop. And of course you can attach joint geo if you want to. I actually forgot to delete our joints that we needed to first, so let's put down a delete joints node here. And we'll get our neck and our head. Perfect. And now we have our FK chain right off the bat. Our IK chain, or look at chain, is going to be a series of constraints, a series of look at constraints that are going to look at a point in space. Now we actually want to add this point in space before we start to solve for things. So we actually need to go and grab our look at. And since we don't have a look at point yet, let's create one. So let's just put down an add sop. We'll create a new point here. We'll put it relatively in front of his face, like so. Call it add look. Give it a name. And we need to give it a rig doctor as well, so that we can initialize transforms on it. Then we can merge it with our main chain. There we go. Set up a parent node here. I'm actually going to move all of this stuff just over a bit. I'm actually going to set this up after our spine has been merged, because we don't need it prior to our spine being blended in. We just need it after for the solving of our neck and our head. I'm just going to parent this look under the root. Our name didn't take because it's on primitives, so we'll change that to point. So long as our joint number is correct, this parent system will still work properly. Perfect. Now we can add this into our delete joints, and we want to make sure we grab it as well. Now wherever the root moves forward, we're blending, we're taking our root after, or rather we're taking our look at point after our root has been moved. I've actually just made a mistake in terms of where we've made our root, or where we've made our look at. We'll notice that we run into a similar solution or issue we did earlier. When we move our root, since we're adding it after the fact of our moving of our root, it will be parented after that fact as well. So something that we can do to solve that issue is we can, of course, take our look at joint here, and we can add it in above our FK legs. We can add it into our capture system here. We can see that I did so with the root. So let's just add our look at inside here as well, and we'll parent it under the root. Perfect. Now when we move our root, our look at should move with it. Great. So now we have the needed components for our neck and head to be looking at. Let's add in a rig pose here to control where that look at is, and that's all this rig pose will be used for. Rig pose look at FK neck. Now let's build our look at system. First off, let's talk about if we want this aim to follow along with different spaces. Let's say we place our character with the root, so our aim is at the correct point, but then we want to animate our character just moving forward with our cog and our eye case, how we would normally. And we want that aim to move forward with the cog. Well, right now we'd have to animate that point, this control, the same movement as our root. Why can't we just make it follow the root and we don't have to edit it as much? So let's set that up. We're going to do so with a system of parent constraints, just by including a parent constraint and allowing our animator to choose the blend on this parameter. It can follow different parents. So we'll want our main chain before we delete everything out to be our second input, so we can grab those joints prior to our neck being operated and prior to our rig pose. And prior to our rig pose here, so that before we edit the position of our point, we're editing what it's parented under. So we will aim parent is what this operation is going to mainly be doing. Let's get our look at set point transform here. We'll put our X form in like such. we'll also want to get its position, and this is the X form that we want to be editing. We'll get our root, and this is our current parent, and we'll get our cog, which we want to be able to be our new parent. Just like that. No change has occurred, but if we were to, hopefully if we were to move our cog at this point. So once again, I have, it's real bad when we have our FK in position there, like that. So something I just stumbled upon, as we may have seen there for a second, was that our leg got really messed up for a second there. And that's because we went back and we added a point to our joint chain system. And sometimes when we do that, our match by name aspect of our IK chains gets messed up. So if we just unselect that and reselect it, it'll rethink it through and fix our matching by names and kind of solve that IK chain again. So I've set up our constraint to follow our cog here, and we can see it does so. We just need to update the offset. So that it's not way up in the sky. Now when we blend, we are blending, it's remaining at the same point, and we are choosing whether it's blending with the root at 0 or with the cog at 1. Okay, so let's get started on those aim constraints for the neck. So we're going to do this with a rig VOP. So we'll just put down another rig VOP here. And I'm going to clear our movement on the look at point there. We're going to want to grab our look at point here, and we don't need our set transform, we just need the get transform since we're not trying to set where this position is. And we're going to need our neck, and we are going to need its get and its set. So there we go. And we'll put down a look at constraint here like such, and we'll put in our X form for our look at and our X form from our neck as the X form that we're constraining, and we'll output our X form into our neck set. Now we'll notice our neck just immediately aims full on at our point because of our look at axes here. If we turn on our joint axes, we'll see that our our Z positive is pointing at our neck, which we don't want. We actually want our Y negative to point at the neck, since the Y positive points towards the back of our neck, the front of our neck is Y negative, and we want our Y negative to point towards that. Perfect. Then our up axis is Z positive, exactly how we have it. So that's great. Our neck aims a bit too much from the base of the neck straight at that point. I'm going to set this blend to be like 0.2 and work our way up the neck as we go. So I'm just going to copy this and change the name to be neck 2, and we'll have neck 2 as well. And now we can see that if we increase this value to be like 0.4 or something, now our neck 2 aims even more at the point, and we could keep doing so for our third neck, neck 3, neck 3. We can make this like 0.6, and then we can have finally our head, which we can just rename here, head, head, And we can make that something like 0.8 or even 100%. Now let's see what that looks like when we put it into our main chain, when we blend it in, and we can see it deform the mesh. So here we'll set up our skeleton blend for our neck blend. Perfect. We'll keep it towards our left so we can see their aim system, and we'll blend in our main chain, which will be just straight from our spine. There we go. World space, taking our neck, and we'll put it into our bone deform here. Now when we edit our look at, we can see we get neck rotation and aiming set up here. Perfect. It works pretty well, I think. We get slightly more rotation as we work our way up towards the head, so that the whole neck isn't just craning up to look at this point. We also get a nice twist in rotation this way, as we can see. It's pretty nice. Looking down has some limitations, since you mostly look down from the base of your neck, but looking up and to the sides has a lot of advantages to doing it this way. So that's looking at the neck. Perfect. So go ahead and package this all up into an HDA, create a new spine HDA that we can put down at any point to edit the spine how we want to, create promoted parameters for all aspects that you want, and lock off all others that you don't want.